Okay, so I want to create a video about how to simplify fractions. And to begin with, a fraction, remember, is part of a whole. So if I have a whole candy bar and I give part of it to my son, then I would be giving him a fractional or a fraction of my candy bar, right? So let's say I want to give my son 3/6 of my candy bar. So the denominator tells you how many total pieces I'm breaking my candy bar into, which in this case is 6 pieces, and they are all of equivalent size, those 6 pieces. And the numerator tells you how many of those you're interested in. So how many, in this case, I'm giving away to my son. In this case, I'm giving him 3 of the 6 pieces, right? Okay, that is a fraction. And there's nothing wrong about this fraction. That's exactly what it is, 3 out of 6. It's a perfectly legitimate fraction, but it is not as simple as it could be. So, what does that mean? It means if I took this candy bar and I wanted to give my son this amount of candy bar, this green amount here, I could do it without having to break my candy bar into 6 pieces. In this case, I could actually just break my candy bar in half and give him all of that, right? See how that's simpler? You're breaking it into fewer pieces, right? You're cutting into fewer pieces. And indeed, if he had 1/2 of a candy bar, he would be eating the exact same amount of candy as if he were eating 3/6. So we can say that 3/6 and 1/2 are equivalent fractions. They are exactly the same. One way to test whether they're the same, just to prove it, is by doing what some students call the butterfly, by finding the cross products of this. Really, this is, we'll get into this later, this is a proportion, really. And so what that means is that if you multiply the diagonals, you should get the same product. So 3 times 2, which is 6, should be equal to this diagonal, 6 times 1, which is in fact true. 6 equals 6. Okay. Now, here's a question. So we know that 3/6 and 1/2 are equivalent fractions. We can tell that pictorially. We can tell that by testing with the cross product. Here is a question. How can I determine what the simplest fraction is given 3/6? Right? How do I know that I can simplify it to get to 1/2? Why couldn't 3/6 be simplified into, say, something over 3? Maybe 1/3, right? Well, visually, we know that 1/3 and 3/6 are different because they don't look the same. They don't match up, right? 1/3 actually happens to match up right there, and this does not match up to any lines here, okay? So they don't match up. So you can kind of thinking of simplifying fractions as a way to match it up, but not to get rid of as many lines as you possibly can inside of that fraction, okay? So here's how we can tell, right? We can simplify fractions by finding a common factor within the numerator and the denominator. And in fact, in this case, we're looking for the greatest common factor. That'll make it simpler, make it faster. You can find the greatest one. So what do I mean by greatest common factor? All right, well, a factor is a number that when you multiply it by another factor, you get the product you're looking for. Okay, so for example, my numerator is 3. Right? So the factors of 3 are any numbers that when you multiply them together, you get 3. So let's try this out. What times what equals 3? Or in other words, I'm thinking about two numbers. When you multiply them together, you get 3. What are my numbers? They're 1 and 3. Right? 1 times 3 is 3. Okay, are there any other numbers? In this case, no. Right? There's nothing else. All right, so let's do the same for our denominator, 6. So I'm thinking of two numbers that when you multiply them together, you get 6. What are they? Well, you could multiply 1 times 6, but you could also multiply 2 times 3. Right? All right. Now, here are all the factors of 3. 3 happens to have two factors, 1 and 3. And by the way, any number that has exactly two factors is called a prime number. So 3 is a prime number. 6, however, has 4 factors, so it's not prime. It has 1, 2, 3, and 6 are its factors. And so now I'm looking for any factors that they share in common, right? Common just means that they're sharing them, that they both have them. My son and I both have something in common, and that we are boys and we wear glasses, right? So that's our common factors. In this case, they both share a 1, and they both share a 3. Okay? So 6 and 3 have 2 common factors, 1 and 3. Now, the greatest common factor is which of those two numbers is greater, 1 or 3. In this case, 3 is your greatest common factor. See how that works? So here's what you can do. I can actually divide both my numerator and my denominator by the greatest common factor, and that will simplify my fraction. So if I divide my numerator by the greatest common factor, and I divide the denominator by the greatest common factor, I'm going to end up with, let's see what I got, 3 divided by 3 on top, and 6 divided by 3 on the bottom, 1/2, just like we saw in the picture, 1/2. Now, you say, Mr. Baker, how come you can't just divide fractions? That's kind of weird. You divide the numerator by 3. Well, the thing is, what I'm really doing here is I'm dividing by 3 on both the numerator and the denominator. And so really what I'm doing is I'm dividing by 3 over 3, right? And 3 over 3 is just 1. You can always divide or multiply anything by 1 without changing it. That's called the multiplicative identity. 1 doesn't change things, right? 5 times 1 is still 5. 8 divided by 1 is still 8. 12,243,000 divided by 1 is still 12,243,000. I hope I said that right the second time. Right? So dividing by 3 doesn't change my result, but it does simplify my fraction. Right? 3 over 3. All right, here's a shortcut now. I like writing my factors in this way because this already simplifies my fraction. All right, my simple fraction is the neighbor of the greatest common factor inside my table. So remember, we're looking at 3/6 trying to simplify it. Well, once I find my greatest common factor, my simplified fraction is actually right next door. 1 is my numerator, and 2 is my denominator. So let me give you another example of what that looks like. So let's simplify the fraction. Let's simplify the fraction 18 over 24. Okay, so I'm going to simplify this fraction. I need to find a common denominator. Sorry, no common denominator. A common factor between the numerator and the denominator, 18 and 24. So I'm going to write 18's factors are 1 times 18. 2 times 9, and 3 times 6. You can keep going, you can keep checking, right? Just you keep getting larger and larger and larger. So does 18, is that divisible by 4? No, it's not. Okay, is it divisible by 5? Nope. And you can stop because at that point, because 6 is already on your list, right? You just keep going up and up and up. So I can stop there. 24, I'm going to find the factors of 24. Let's see, 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Now, 5 doesn't go to 24, and 6 is already on my list, so I can stop there. All right, which factors do the two numbers share in common? Well, they both have a 1, they both have a 2, they both have a 3, and they both have a 6. Okay. Which of those factors do they share in common is the greatest? Well, it would be 6. And here's my shortcut. My reduced fraction will just be the next door neighbor of that greatest common factor. So in this case, my reduced fraction will be 3 over 4. How that works? Now, really what we did was we divided by 6. But by setting my table up like this, I already did the division. It's right there in my table. So my simplified fraction of 18/24 would be 3/4. All right, that's pretty much it for simplifying fractions. We'll have another video for converting from an improper fraction to a mixed number and vice versa. Let me show you one more trick, though, you can use if you happen to have a times table. So I'm going to simplify this fraction. Let's say we're going to do, let's see. Let's do 78, 90 over 91. All right, there's my fraction. Okay, here's one trick you can do if you have a multiplication table, and I happen to have one. That's how I created this fraction. In fact, I'm going to zoom in a little bit here so we can see this better. Okay, remember, we're looking for a shared factor between 78 and 91, between our numerator and our denominator, and we're going to divide by that shared factor. So in a multiplication table, the whole reason we have a multiplication table in Whitehouse is because it shows us what numbers are multiples of each factor, right? So if I can find 78 and 91 either within the same column or within the same row, that means that they share a factor in common. So I'm going to look in my table. I'm going to look for the numbers 78 and 91, and it's always the best to look from the bottom, from the largest numbers, and work your way up. That way, the first thing you find will be the greatest common factor, not the least common factor. Right? So I'm going to look for the number 78. Right? So if I look through my multiplication table, I can see 78 is right here, and I'm going to see, okay, so is 91 also in this row? Well, in fact, it is. It's right here next door. So because these two numbers are both in the same row of a multiplication table, I know that they share a factor in common. And in fact, the factor that they share in common is 13, right? Because it's in the 13th row. So I could divide both 78 and 91 by 13. That is their greatest common factor. Now, you could do the division, but a shortcut on my multiplication table is it tells me exactly what that factor is. What times 13 is 78? Well, it's the column it's in, which in this case is in this 6th column. So, and 91 would be 7 times 13. So my simplified fraction is going to be 6 over 7. Okay, let me give you one more example like that. So we're going to do another example of a fraction that I could simplify based on my times table. So I'm going to do, let's say, 48 over 80. Okay. Now, a lot of you might look at this fraction and think, okay, well, they're both even. We can divide by 2. And that is a legitimate way of doing it. That'd be totally fine. But you might have to simplify more than once. If you start off by finding the greatest common factor, that means you only have to simplify one time. So I'm going to look at my table. I'm going to look for, in the same row, I'm going to look for the numbers 48 and 80. So let's see, there's no 48s here, no 48s, no 48. There's a 48. Is there an 80 in the 12th column, though? There is not, right? Okay, 48, 48, 48. There's a 48. Is there an 80? There is. So 48 and 80 both share a factor of 8. So if I divide those both by 8, I will get, and this is in row number 6, and this is in, I'm sorry, column number 6 and column number 10. That doesn't seem right, does it? Well, let's try it. So it'll be 6/10, right? Now, here's why I'm saying this doesn't seem right. Because 6 and 10 both share a common factor as well, right? I know what I did here. Well, I can divide both of those by 2. I can divide that by 2. I can divide that by 2. And I get 3/5. Okay, so Mr. Baker, what does that mean? That means, first of all, we simplify the fraction, right? Second, though, when I divided by 8, 8 wasn't the greatest common factor here between these two different numbers. I was using a multiplication table, and 8 is the greatest common factor on my table, but there's one more common factor that's greater than 8 that's not on my table, and that is 16. If 16 were on my table, then yes, indeed, there would be a 48. It'd be right here, 16 times 3. Oops, 16 times 3 would be right there, right? And there would be an 80 on my table because 16 times 5 is 80. So, yeah, you can take that as you will. And maybe that was a success, maybe it wasn't. But when I simplify my fraction all the way down, I get 3/5. And that does kind of show us another interesting thing. If you get halfway through and you get to 610, you can use your multiplication table again and look for 6 and 10, which in this case both appear on the 2 column, and that simplifies down to 3 and 5, right? 3/5. So there it is, my video about simplifying fractions.